Hello, grade 11s. In this video, we are going to look at identification of the organic molecules, alkanes, alkenes, alkynes, haloalkanes, and alcohols. First, let's look at what is homologous series. Homologous series is a group of it is a group of organic compounds that have similar structure and contains the same functional group. Now, the homologous series we're going to talk about are 1. Alkanes, alkenes, alkynes, haloalkanes, alcohol, aldehydes, ketones, carboxylic acids, and esters. These are the homologous series we're going to talk about. So the homologous series, they are described by the same functional group. Now, what are the functional group? The functional group is a specific group of atoms within the molecules that describe its chemical properties and reactivity. It is a region of the molecule where chemical reactions occur. If we take the alkanes, their functional group is what we see here, that is carbon, hydrogen, single bonds, and carbon-carbon single bonds. So whenever we see a molecule that has carbon, hydrogen, and carbon-carbon single bonds, that molecule is alkanes. Now, the alkanes, their functional group is the carbon-carbon. If we see carbon-carbon double bonds, that is an alkene. So the functional group, the structure of the functional group of alkanes is this. And when we have alkynes, the functional group is carbon-carbon triple bonds. So the structure of the functional group of alkynes is this. So whenever we see carbon-carbon triple bonds, we should know that the homologous series to which that molecule belongs is alkynes. Now, if we have an alkanes has carbon, hydrogen, and carbon-carbon single bonds. If we have an alkane which is now bonded to any of the halogens, then that is haloalkane. That is the homologous series, haloalkane. And the structure of the functional group of haloalkane is you have carbon single bonds with any of the halogen. The X here stand for any of the halogens. Now, the halogens can be fluorine, it can be chlorine, it can be bromine, and it can be iodine. Now, for alcohol, whenever we have carbon, hydrogen, single bonds with a bond of hydroxide, that is the OH bond, we call it hydroxide group. Then we are talking about alcohol. So the structure of functional group of alcohol is seeing carbon, hydrogen single bonds in addition to the hydroxide bonds. Now, in this video, we are going to only concentrate on these 5. 1, 2, 3, 4, Okay, only going to concentrate on D4. Okay. Okay, let's say five rather. Alkanes, alkenes, alkynes, haloalkanes, and alcohol. All right. Now we have explained what is the functional group. Now we're also going to look at what is the condensed structural formula. Now for the condensed structural formula, it is a way of writing the structure of a molecule, showing all the arrangement of the atoms and bonds in a concise format. It omits some or all of the bond lines, making it a more compact representation of the molecule's structure. For instance, we have learned in the previous lessons that whenever we have all right, we've learned that whenever we have a molecule like this, yeah, this is the structural formula. But however, we also learned that this can be represented by this. So this is what we mean by the condensed structural formula. Writing the molecule by omitting all the bond lines or omitting some or all of the bond lines. We can see in this format here, we do not have the bond lines. So when you write it this way, that is the condensed structural formula. When you write it this way, that is the molecular formula. All right. So now when we talk about the molecular formula, okay, condensed structural formula and the structural formula. When you talk about the molecular formula, that is a formula that indicates the number and types of atoms present in a molecule. For instance, if I have, let me say, if I have C, if I have C, all right. Now, if I have this, or let me just even use use a different molecule. Now, the molecular formula is now to indicate the number of and types of atoms present in a molecule. So if I take the C, I should know how many atoms of carbon atom do I have? I have two. And then now, how many of the what you call? How many of the hydrogen atoms do I have? I can see that I have 6. So this is what we mean by molecular formula. So if you're able to draw the structural formula, you should be able to write its molecular formula. Or if you're able to draw the condensed structural formula, you should be able to write its molecular formula. So now we are now going to move on to look at how do we identify our organic molecules. Okay, we're going to start with alkane. alkanes. Now, for alkanes, we've learned that for us to know that this is an alkanes, we first of all have to look at the functional group. Whenever we see carbon, hydrogen, and carbon-carbon single bonds, we should know that that molecule is an alkane. All right. For instance, if I have this is what I have. Now, this is an alkane. How did I know? Because it has only single bonds. So carbon, hydrogen, and carbon-carbon single bonds. It refers to an alkane. Okay, so the homologous series is alkane. Now, this is what we call the structural formula. But if I want to write the condensed structural formula, if I want to write it condensed structural formula, then all I have to do is I have to write my C, first C, and then ask myself, how many hydrogens do I have surrounding the first carbon? I have 3. And then I have to write my second carbon. And then how many hydrogens do I have surrounding it? I have 2. And my third carbon has 3 hydrogen. So that is the condensed structural formula of that molecule. Now, I can also write the molecular formula. So the molecular formula I need to know how many C do I have in total? How many carbons do I have in total? I can count it from the structural formula, or I can count it from the condensed structural formula. Now, if I have to count it from the condensed structural formula, the first has, I have 1, 2, 3. So I have 3 C's, so I have 3. I have to write it. And then the H, I need to count the number of H in total. So I have 3 plus 2 plus 3, which is 8. 8. That is my molecular formula. Now, I have to also look at the general formula. Now we have what is called the general formula. So for the general formula, you always have to start with the carbon. The N stands for the number of carbon you have. And then the number of the H, you multiply 2 by the number of the carbons you have. And then after that, ask yourself, does it match to the number of carbons you have in the structure? If not, what do you do? Now, let's see how we go by this. If I have to take the condensed structural formula here, I can see this. I have 3C, 3 carbons. Now, if I have to multiply 3 by 2, I'm going to have 6. Then I need to ask myself, do I have 6 hydrogens? If not, what do I do to that number to get the number that I have? Now, I'm going to count I'm going to now multiply. I have three carbons. So if I multiply 3 times 2, I'm going to get 6. But then, do I have 6 hydrogens? I have 2. I can see it even here. I have together. Total is 8. But when I multiply 3 times 2, I got 6. So what do I do? 2, 6 to get 8. I have to add 2 to it. So that is my general formula of the alkane. Now, we are done with alkane. How to identify alkanes? We say we have to watch out for single bonds, carbon hydrogen or carbon carbon single bonds. All right, and then we have also learned how to write it condensed structural formula, the molecular and the general formula. Now, let's move on to the second example, which is alkyne. We're going to look at how to identify alkenes. For the alkenes, we have to watch out for carbon-carbon double bonds. So whenever we see carbon-carbon double bonds, we should know that we are dealing with alkenes. For example, and here, to arrange the bonds, this C has 3, so it needs 1 more to become stable. Then the last one has 2, so it needs 2 more to become stable. So this is an example of an alkene. So now to write it condensed structural formula. The first now condensed structural formula. The first the first carbon has 3 hydrogens. The second one has 1, and the third one has 2. So that is the condensed structural formula. So how do I write the molecular formula? To write the molecular formula of the same alkane. Now, I need to ask myself, how many carbons do I have in total? I have 3 carbons. I have 3 carbons. That is, if I have to count from here, I have 1, 2, 3, or 1, 2, 3. So therefore, I can say this carbons, I have 3. Now, let me count the H. To count the H, now I have, if I have to count from the structural formula, I have 1, 2, 3, 4, 5, 6. Or I have 3 here, 3, 4, 5, and 6. So I can write it with a subscript 6. That is my molecular formula. Now to write its condensed structural formula, to write its general formula, I have to start with the the CN H2N. And then I'm going to now multiply 2 by the number of the carbons I have. And the number of the carbons, I know that I have 3. So if I multiply it by 3, I have to get 6. Then I have to check this 6 with the number of the H I have. If it match, then I have to maintain the formula. If it doesn't match, then I need to ask myself, what do I do to get the number of the H I have? Now, in this case, it matched. I got 6, and I have 6 from the condensed molecular formula, or the condensed structural formula, or the structural formula. So therefore, this is the general formula of the alkanes. All right, now let's move on to the identification of alkene, alkynes rather. For me to know that this molecule is an alkyne, I have to see carbon-carbon triple bonds. So whenever I have carbon-carbon triple bond, we call this the structure of the functional group. Then I should know that I am dealing with an alkyne. Now example, this C in the middle here is okay. Why is it okay? Because it has 4 bonds surrounding it. It has 3 bonds here and 1 here, which makes it 4. And carbon can form the maximum of 4 bonds, so it is okay. But now this one, this C here, the last C has 3 bonds, and it needs 1 to make it okay. So therefore, we can just add 1 to any side of it to make it okay. So now, to write the condensed structural formula of this is going to be the first carbon has 3 hydrogens. The second carbons do not have any, and the third one has 1. So that is the condensed structural formula. Now, let's move on to the molecular formula. So, molecular formula. For the molecular formula, I have 3 C's. And how many H's do I have? I have 4 H's. Sorry, the 3 C's and 4 H. Now, what about the general formula? So the general formula, I have Cn always, H2N. That is what we always begin with. Now, whatever is added here, you have to just take the number of the C. In this case, the number is 3. And then you multiply it by 2. You get 6. So now this 6, compare it with whatever you have. And you can compare it with the number of the H, either here, or you can compare it also here, or you can compare it also here. So in all cases, the number of H is 4. So if it is 4, ask yourself, what do I do to 6 to get 4? I hope you all agree with me that we have to subtract 2 to get the 4. So this is the general formula of alkynes. Now, let's move on to haloalkanes. So our next example is haloalkane. For the haloalkanes, we have to watch out. We have to look. For me to know that this is an haloalkane, I have to see carbon, carbon, single bonds, carbon, hydrogen, and carbon, carbon, single bonds with a halogen as an attachment. Okay, just like alkanes. Okay, if you have alkanes, but you have one of the attachments to be one of the halogens, then you should know that, oh, this is haloalkanes. So the structure of the functional group is single bond, and this X can be either iodine, either bromine, either